Hello everyone, I'd like to welcome you to my video once again. My name is Maxwell and I am the owner of Career Tech Explorer, where I teach you various techniques, various skills regarding research, data analytics, and engineering as well as technology. Today I want to present to you how you as a teacher can use RStudio to manipulate educational data in such a way that it will help make your work easier. So come with me as we dive in. Before then, I'd like to draw your attention to the fact that if today is the first time you have encountered my video or my videos, either on TikTok or YouTube, please do well to subscribe or follow my page to help encourage me to continue to do this stuff. Thank you very much. Let's dive in. Okay, so to use R, all you need to do is to first create a new script, and to create a new script is you just hit on this plus button over here, and you can see new file showing up. When you click on it, you see R new scripts. It will take you to a brand new space where you begin to do your analysis. Now let me use the already created one so that I can make things faster for you, and we can work together at a much faster speed. The first thing you need to do after creating your script is to set your working directory. To set your working directory, I would like to show you the folder live streams. This is where the data I'll be sourcing the data from. Alright, so that's the reason why in setting my working directory I have used documents, live streams. So the working directory is set for that. And if you go over again to the folder, you will see that I have about 8 data sets. 1, 2, 3, 4, 5, 6, 7, 8, actually 9, 10 data sets, SS2A, all the way to down to SS2E. So now you import the data. How do you import data to R? Set whatever name you want to set. In this case, I decided to use the same file name that we have SS2A, and then use the less than sign and a minus sign. Then you use the function read.csv. Then insert the file name including the file extension. These files that we have over here are in .csv, so you will now include .csv. After doing that, for each and every one of the files, you can just highlight all of them and hit the run button. So then the script will run and then import the data into the space. Now the next thing we need to do is that we're having two sets here, the ones that are just A, B to C, and the one that are having SS2A-2A to E. Okay, so the A to E will be matched, each of them will be matched row wise. That is why I have SS2 row. So SS2 row will merge using the R bind function. It will merge SS2A down to SS2E, and then SS2 row 2, which is this other sets, I will now merge that also using the R bind. So what happens in the data is that, for instance, if we do this one, we will see that using the view function SS2 row, when we view it, we will quickly see that it is having English, mathematics, biology, chemistry, physics. This is one different set of subjects, all the way to about 226 candidates or students. Now, for For the second row, which is row 2, we can also view that by using the view function, and that is SS2 row 2. When we view that, we will see that we're having another set of functions, another set of subjects, which is geography, agric, economics, civic education, then religion. So that is what we have. Okay, so this is what we have. Then that is what we have. The next thing we need to do now is to merge these two together, and to merge the two together, we are using the cbind function. That is where I got SS2 data. So when you run this, you click here and you run it, you are going to have the data merged. Now let's view it. When you view it, you can see that we're having English, Maths, Biology, all the way to religion for the same set of students, and these are their serial numbers. Okay, so for further processing, we could check for, let's say we clean the data. Let's check for missing values. Checking for missing values, we use the function, let's say we use the same data, SS2 data, and then we assign the vector name. We want to say some is NA, sorry, sum is .NA, which is missing value. At this point, I will need to create a column for total score. And to create a column for total score, typically you will use the $sign to introduce that. As soon as you press the $sign, which is obtained by Shift 4, you're using a Windows device, and then you type in the name of the column that you want to introduce, and that is total score. Now I want to sum the rows for SS2 data for the subject English, Maths, Biology, Chemistry, Physics, all the way to the end. Alright, so this is the function that you use. Okay, so SS2 data is this. Fine. Okay, this is the problem. We should have delivered this and say missing. Alright, so that this will be missing. Okay, so the problem here was that we labeled, and let's say we're checking the missing values, which is what we got here. Okay, now so SS2 data, we have created a new column, and to view that column, you can now say view the data now. We view it using the view function. SS2 data. We'll see if a new column called total score was created. Indeed, it was. Alright, so that is how you create that. The next thing we need to do is to sort the data using the main column, but we do not have a main column here, so it is total score that we have. So let me just adjust this now. So to sort the data using the total score column, you tell us the data that it is the sorted data, and you call SS2 data the way it is. That you use the function order in a square bracket, and then using the negative sign means that each order will be in descending order. Right? So we sort that. If we go back to view SS2 data, pardon me, if we now view SS2 sort, if we view SS2 sort, we will have that the data is sorted in a descending format. You can even see that the registration number is no longer starting from 10001. Alright, so 674, 671, and so on, the way down. So this is how the data is sorted. The next thing we need to do here is to this is a different thing. Okay. Alright, so this is needed. Okay, so there's something we need to do here now. We need to sort the data by the maths column. Alright, so when we sort the data by maths column, we now have this. There's something I'm getting at. When we sort that by maths column, you see that maths is now coming down from 70 down to 68 and probably down to 40. Okay, so and I want to hold maths in place and also sort only the physics column. So I created a new data set that only has something to do with chemistry and physics. Alright, so and that is now called U1, chemistry and physics. We're having only chemistry and physics because now I want to check if performance in mathematics can help boost performance in physics. Alright, so that is now called new 2. New 2 now have something now to do with the data new 1, order new 1 in descending order using the column of physics. When that is done, we have this. Okay, when that is done, we have this. Alright, so you can see that physics is in a descending order. Okay, so one other thing that we can also do is to arrange in sort 2. We can simply just keep, and we now come and say data 2 is SS2 data B is now combining where physics is arranged. That means only physics. I'm sorry, we need to run the apply function library. Then we will need to now create another data called sort2. Now to check out sort2, this is what sort2 looks like, right? So this is what sort2 looks like. So now we're now creating SS2 data B, combining SS2 sort with SS2 sort2. Okay, so when we run this, we now have the new SS2 sort B is now this. Okay, now you will notice that we're having chemistry physics here and also chemistry physics here, and we're interested in this physics but not this one, and we are interested in this chemistry and not necessarily this one. So we're going to remove those from the data frame now. So that's why we're deleting chemistry physics. Okay, so we say subset use the subset function for that. Subset SS2 data B, select where it is equal to chemistry and physics. Put a minus sign. That will delete those two. Okay? We'll delete those two as well. We are still viewing. We will see that the chemistry and physics here are now gone. Alright? Okay, so we now need to move this chemistry and physics over to the position where they were initially. Alright, so to do that, you use this particular script here. I'm moving them to the 5th and the 6th position. So you say SS2 data B using the square bracket, and you say column names, the column function, that's C function, names, SS2 data B, and square bracket 1 to 4 will be in place. 1 to 4 will be where they are. Then chemistry and physics will now follow. Then after that, names SS2 minus the C function. That means every other thing after that was there initially, after including chemistry and physics, will maintain their position. Alright, so when you run this, you arrive at this particular okay. We arrive at this. Now, having gotten this, we now have to delete chemistry.1 and physics.1 because they are no longer needed. Let me see what happened here. Okay, good. So they are still replicated here. So these two now are no longer needed. The ones we needed have now flown over this place. Alright, so we now have to delete Chem 1 and Chem and Physics 1. When we do that, we have this. So chemistry and physics are moved over to this space. Right? Next, can now rename this SS2 data B. Can now rename it back to SS2 data, just SS2 data. Alright. So, okay. So next, after renaming that by using this function, then next we'll create a column for me. Create a column for me, and how do you do that? Use the $sign and write the name of the column you are creating. Then O means, this is a function for calculating O means in the data, SS2 data. And then using the C function, make a list of all the columns that you want to be involved in this calculation. So this was done. And then we have this. If you want to view it, sorry, to view that, we use the view function. View, and then we say SS2 data. Okay, you can see that a main score column has been created. Alright, mind you, we're no longer interested in this sorting per se. We have now sorted according to the initial thing that we went that we became interested in. Fine. Now, at this point, we want to rank. You know, most of the times as a teacher, you are sometimes confronted maybe in a scholarship situation. You need to know who is in the first position, who is in the second position, who is in the third position, and so on and so forth. And to do that, we use the rank function. But then at that point, we first create the column name. And the column name is position in class. Remember to introduce a new column by the use of $sign and then the column name that you're interested in. Alright, so using the rank function, then minus sign. This minus sign is used so that it will make it flow in like it will arrange the mean score in a descending order. Right, so now we're interested in arranging the mean score in a descending order. But then the ties, that is we're using the ties method. That is the ranking, the first position, second position, third position that we used. The minimum position will be assigned to the highest mean score, as you know that it is. So we're using the ties method. So when we run this now, what we get is we have let's see what we got. It works. Now the arrangement didn't work. Okay, so we then correct that by using order. So we ask the program to order RStudio data using the mean score column. So when that is done, then you view it now. You can see that we're having first position down to the 226th position. Of course, if you are a trained teacher, you know that where you have two persons having the same position, then the second position will not be there. Alright, so this is going to be the first and this second. Now this is 4 days, 50, 60. Now you can see that we have 6 in 2 places, so therefore we are not having 7. We are not going to have 8. After then we have 9 positions in 2 places. Like that. That's how positions are assigned in education, for those of you who may not know. Now guys, if you're enjoying this video, please hit the subscribe button and then share this video with your friends and family. Finally, you will do well to say, okay, you want to perform a summarization, a data exploration to see what is the minimum, what is the mean, what is the mode, what is the median, and so on of each of the column. But let's just demonstrate an example. It's the English column. For English column, what we have is that the minimum is 60, the first quartile is 62, the median is 65, the mean is also 65, the top quartile is 68, and the maximum score is 70. For maths, we have the same thing, right? You have 40 as the minimum score, maximum score is 70, and other parameters are supplied. Then I wanted to also demonstrate to you how you can, as a researcher, check in an experimental situation to see if performance in maths can affect performance in physics. So, and to do that, we use the LM test library, that is the linear model test library. So when you call that into action, you first need to fit your linear model, and to do that, use the function LM. So we are seeing physics being the dependent variable. Let's now see maths as the independent variable. Remember, this is called tilde. Okay, so and the data we are working with is RStudio. So when you run this, you will have this. If you want to check the summary of your model, this is what you got. This is what you got. So what do you have? We're having that the p-value is 0.00000016 places. Get it? It's less than this. So which means that yes, the hypothesis that said mathematics helps in predicting performance in physics is true. All other things here are just voluntary activities for visualization.